Hey, welcome again. So this is chapter 2. So what we're gonna do now is that we're going to animate these edges so they kind of like come apart. So it will allow us the rest of the area to fall off, right? So we have this left and right, which this geometry is not gonna change really. So it's a matter of just then hand selecting these guys. So I'll call this, so I basically select on the viewport, I hit tab in the viewport group, and we're gonna get a group. We're gonna call this guy left, let's say land. All right, and we'll do the opposite. Just picking up a little piece on the other side. No, it's like this. Yes, group. So we're gonna call this R, which is the right land. So don't move to the left land. I made a joke. All right. Then what we can do is, cache this out a single frame. Actually, do we need to? Because it's already doing this from here. We don't really need to cache this here. I have cached it. I don't know why. Because it's not even animated yet. So then let's put a transform node. So we are going to animate left. So if I do anything, it's just going to affect the left side. And then we'll do the same thing. So this is, let's say, left animate. Put another transform. Right animate, and from the groups excuse me, we change it to right. Okay, so we have the left and the right. So let me check my keys. Actually, I'm just gonna probably copy these guys. As you can see, I did not name my objects, which is not cool. So I have the keys here. If you don't want to key it, you can just copy from my scene file, obviously. Which reminds me, let's save this as landscape part 2, or actually, well, this is part 1, so let's call this part 2. Let's rename this to part 1. Yes, we do that. Let me do that now, so don't forget. It's gonna be here. Okay, so it's gonna be, let's rename this to 1. Okay, so it's kind of a bit more in shape once you guys receive this. Okay, so this is now left animate, this is right animate. Okay, and if I press play here now, things should start moving, but they are moving the wrong way. It was gonna be, this is, I guess, yeah, this is right then, this is left. And let's do it like that, and like this. Now should be okay. Yes, okay, so now our land is separating. The other thing I did is so let's call this now. So this one is for rendering on the ground. Animated ground render. I thought it's dry. So what I did also is I did the same thing, however, a proxy version. A proxy version that also is a little different proxy version. You'll see now why. So let's the names are coming from up here. We don't need those names for rendering. We can't do those cleanup before animating, actually. Attribute delete. So let's keep position, of course. Let's get rid of name. Okay, it's a bit more clear. So let's go here, and let's go here. Now let's get left and right. And what I did is that I put a TED embed because we're gonna use guide geo, and I wasn't sure if it was okay to have such big spaces because we're gonna have some building pieces going inside these areas. Okay, so I am not sure if we want to have those spaces. So what I did is, I'll show you now. Let me get this number right, because if you have a small TED number, it's going to take like a year to fill that up, and we don't want that. This should be okay. Let's put this in. Okay, so this is like a much lighter version. Also, it has points inside text. So if you are using guided geo, I think it just has a much better proximity. If you have pieces inside, it will have I think it works better. I don't know, because I had some pieces that were not moving, so I kind of like came up with a solution and it seemed to work, so I am using that. But as you can see at this point, if I do a middle mouse, it's not time dependent yet because we didn't use our animate transform nodes. So let's convert this now to a regular polygon so it doesn't have tetrahedrons. Okay, so now it's all polygons, so as opposed to, let's say, which part is this? Well, we can do the same thing. I don't know why I actually separated them. I probably didn't have to. Let's actually, oh, because the groups probably don't. Yeah, I think the groups don't stay together, so that's probably why I separated these. Because after the TED, I think you lose the group. Otherwise, I could have done the same thing here, but I'm just going to have a look at that now. By doing a middle mouse, I just copy pasted the embed and convert, please don't crash, and paste it. So I'm gonna put this on the class 3, and it's taking surprisingly long. Okay, it did it because, let me check again. Yeah, it loses the group, that's why probably I didn't chain them. Okay, so let's plug it in to this guy, and now I'm going to take the right animate, and I'm going to go actions, create reference copy, and I'm going to put this guy here. So in case I change the animation, it will follow. Actions, create reference copy, I'm going to put this one here. And now if I put a merge one, and I can say, and oh, I think in the previous lesson I was saying I wish there was a way to do the default settings for the color and the null. I think it was Control T. Let me see. I forgot totally yesterday. I was checking for it. I think you go like Control, drag and drop. Okay, let's try this guy. Let's try the cloud. Okay, see, it becomes the default for all the nodes inside your scene. So it's hold Control, drag, and same applies for the color. I think this is super cool. It may actually save a lot of time. So I suggest you guys do the same. However, I think it just follows the chain though. Anyway, so after that, every time I drop a null, now it has the proper naming convention and the color. So let's call this animated ground proxy. You can use this for collisions and volume later on. Okay, so let's line these guys up. I'm gonna turn this on, put on auto, let it cook for a sec. Okay, now if I scrub, it's probably gonna be much faster. Oh, no, because I don't need these groups anymore. Because now it's looking for the groups, but we don't have the groups. Okay. and okay, it's just more responsive. Okay, let's save again. The next thing we have to do is create a VDB of the terrain itself. I have done it before animation. I'm not entirely sure why I did before animation, because I use it somewhere else, I guess. I guess I will not do that now. If I need to, I'll come there and I'll do it again, because I have before the animation here, because animation is here, and before the anim I cached it out into VDB, and I'm not entirely sure why I did it. I'm sure it has a use somewhere. So imagine this tutorial spreads around to a time frame of like 5 months as I prepared. So sometimes some things just are forgotten why they're there, but they are useful. So I'm not going to delete it, but I will keep it for later. All right, let me put let's name these in the network boxes so we remember later on. Then it's just a bit easier to manage as well. So this is the proxy land. This is the animated land, high-res one. Let's call it hero land. So now we have to move forward for our the middle pieces. How is that gonna be? We already made the fractured area here. So what we want to do is to be able to, because we don't want to simulate all these pieces, quite many. So we can do something like split these guys in like 5-6 segments, you know, and then create a simulation accordingly. So what we can do is that, because here it's still like time dependent, so but anything that we need to simulate or fetch information from that doesn't need to be moving, you have to make sure, even if it's it doesn't seem to be moving in viewport, it may have attributes changing. So obviously that sometimes slows things down. So make sure this time dependency is set to no, which means that the data doesn't change, so you can scrub it without any impact. So let's put a box. Let's hook it up. It's going to give us a bounding box, right? So I'm going to put a blast, and I'm going to blast away. I think it's 5 is the bottom one. Okay, it's top one. Then I'm going to put a divide sub. Okay, remove the convex polygon. Put on manual because it's quite a big object. So turn on Bricker polygons. This is what I used. And I said 1000, 100, 200. This actually, the Y is unimportant here. That was a mistake. So basically, I am trying to get 1, 2, 3, 4, 5 primitives here. This is quite important. So this is the value based on Z. So it's kind of like splitting, right? So if you want more wedges, less wedges. So I settle with this many. So this is, let's say, to define wedge area size. Then keep top prim. These are not really that important to name properly, but I guess it might help later on. So let's drop down a wrangle and give these primitives a name. Wedge names, wedge attributes, or wedge attributes. Okay, now switch to primitives and type I at cluster equals at prim num. So we're saying typo prim num. So if we switch to primitives here, it didn't at prim num, no, prim num. Okay, so it's now cluster 0, 1, 2, 3, 4 is equal to the primitive numbers. So I have these separate values, attributes. So these red ones are these guys, and now we have attributes that matches them. So even if I delete any of these, the red ones will change, but my cluster primitive ID won't change. All right, so just gonna put a transform, because remember this is the exact same size. I think I move this down for some reason. Now I just move it up a little bit. I extrude downwards. That's fine. Let's put this on template mode so we can see what we are dealing with. Now what I want to do is just a little, little offset, right? Little offset. Okay. Now what I want to do is that I want to create my wedger wrangle that keeps or deletes what's needed. So let's put another wrangle. You can use blast as well. I'm just kind of used to this guy quite a lot, I guess. So let's call it change wedge, and let's type if so when we got CHI or CHF, it's like channel integer channel float. It's going to create a slider for us on the on this area here. Let's complete it. Wedge cluster ID. There's quite many ways to do exact this thing, but I'm kind of, like I said, used to this. Primnum. Actually, I'm using the primnum. Why am I not using the cluster? Let's use the cluster. We made that for a reason. I add cluster. Okay, it needs to be on primitives. One more parentheses. One. No, that's correct. Tab. Remove prim. 0 means on myself. Operate on myself. Add primnum 1. Remove the primnum and remove the primitive based on its number, and remove the points, leftover points, because we're working on primitives. So now if I click this guy here, it's going to give me this, and if I can slide this slider, that it just, it just stays one. So this is going to be connected to the tops, and the tops will tell it wedge this guy basically for each simulation. So but what is this grid gonna do? Let me show you. Now we go poly extrude, poly extrude. It's like one simple way of doing wedges, really. There's, like I said, many other ways. This one works fine. Let's go -300. Okay, so it's a little close there, but I think our objects are packed, so the point will be always in the center, so we're fine. Let's do output back, so it's closed, all good. Now I want to bring in my simulation object. I want to do a group swap. Left input here, right input here, work on points, call you sim group, keep in bounding regions by bounding object. Okay, and now, oops, let's turn this off. So all this is selected. Now I am copying cluster ID here. Why am I doing the cluster ID? Maybe because I thought I am gonna need it. Probably I will. Attribute copy. Let's keep it anyway. So because we had a cluster ID on prims, and this is 0, so let's copy that also in case. I think maybe I use it somewhere. Occasionally, sometimes when I do this kind of workflows, and then I realize that I forgot to copy an attribute, so then it's easier to follow the breadcrumbs back to the original asset. Okay, cluster match P, this is fine. So now our pieces has the clusters as well. I am promoting this cluster, attribute promote from primitive to points. I will find it why I did that as well, probably down the line. Cluster, first match, and we're deleting version. So then, okay, on the points I have the cluster value. Okay, this is not, I think, correct entirely. Why? Because it all copied the same thing. Because I'm the blast. It doesn't matter, I do the blast after, it will still work. So let's put a blast here, blast, and now let's blast everything that is not sim group. Okay, sim group, delete non-selected. Okay, so now these are simulation area that we want to pass it down. So obviously it's a lot less objects. It's 8,327 packed object as opposed to 45,000. And since like it really doesn't matter, we are always flying kind of like this, and this area in my scene is always in smoke, so you know we can take advantage of that. All right, what am I doing next? I would like to configure these objects now as a simulation. So let's make a box here as well. Let's call this wedge select. Okay, now what we want to do is to prepare these guys for simulation, right? And they're already packed, but I'm gonna unpack them. The other thing I kind of did is that I can do this here again. I put a clip as these were still packed because I think it was proving to be too thick and everything was falling a bit too late. So I kind of, because this area was too thick, and when the gravity was starting, it was taking way too long for this to fall. So I kind of like shaved half of it, and that's the part we never see anyway. So it's kind of like a little optimization again, and it kind of helped. So we can keep that one there, and we're gonna go then unpack. Okay, so now we just have some geometry with name attribute. Oh, good. Now what I want is an Rbd constraint from rules. We can plug left to left. Let it cook for a second. So I create all these constraint networks. You see, I won't be using .NET. You know, bullet object, bullet solver, bullet object, because I found out Rbd bullet solver that this just works fine, and I was like, yeah, I won't use it, and you know, it's like because I think I have to learn it, and I knew the other way around a bit easier for me. But I won't name the studio, but I did a little short contract on a very famous studio, and they told me that they have a workflow around this, and I could do whatever I liked, but I didn't want to stay behind the pipeline, so I kind of used their tool, and then I got hooked. It works amazing. So I really suggest you guys stick to it as well. I am currently, as I'm recording this video, I'm using the same technique for another feature movie that has a huge collapsing object, and it just works wonderful. Okay, let's continue now with the settings. So Rbd constraints from rules. So I want to create from surface points. And it's calculating. It's taking a while. All right. So it may look like it doesn't have, but as you can see, I'm trying to spin the viewport, and it's taking forever. Because it actually has quite a lot of constraints at the moment. So I made the search radius 1. I'm afraid it's going to increase the network a lot, so I'm a little hesitant. So let me save first. And if it crashes, I'll come back to it. Okay, it's really not letting me. Come on. There must be quite a lot of constraints at the moment visible. Okay, 1 second, I'm not going to save now. I'm going to switch this back to first option. I'm going to increase the search radius, maybe it's going to decrease the amount. Come on. Okay, let me pause, guys. We're going to waste the video. Okay, so we're back. I will do a little test before I switch that to the big one. So it's like a little section here, right? Delete, so it's a lot less. It's gonna be much faster to test. Let's go, so let's search for this one. There's nothing else selected. Let's go surface points. Okay, so that's, I can go like this now. Just going to investigate what's the story here. So okay, that's 21,000 points. So if I go 0.5, actually it's a lot less. So this is supposed to be fine. It's really slow. Let me continue with the rest, and then we will switch after. Rbd next one is Rbd constraint property. So the first rule, the first, you can really get close, and as you can see, if you see that like 3 lines, you just drop it, it's gonna connect. So the first guy makes the constraint geo based on naming convention. It just creates points, and then the second one, Rbd constraint, basically tells what kind of constraints these are. And in this case, I went with hard, and I left it as it is. So let's do something like this again. I want to maybe not like this, but because I want to test this. So let's go select something like this across. Okay, so one edge to the other. It's surprisingly taking quite a lot of time, even though that's not that much. Points there, surface points. Okay, let's go here. We can see them now. In between, they're a bit hard to see. Let me try to make them a bit bigger. Okay, quite many. They're in between every single piece. So for performance reasons, it is for starters. We can always start with center of mass. Okay, we can use hinges as well. If you want, you know what each one of these does, just you can go through the documentation. We're not going to read them one by one. It's just that this is how they kind of like move, right? Some of them are faster, some of them are more economical on the CPU. All right, so our pieces have now their glue. So the thing is, I don't really prefer to work on central mass because it kind of doesn't rotate each piece from their edge points, right? So if it's let me draw it real quick. That's because also very important. Okay, it's too bright. Let's fill this with dark color and paint with white. Okay, so imagine we have 2 pieces like this. I cannot see my cursor. We made it too dark. Sorry. Let's do something like this so I can see it. Krita. Let's give him a hard time. Okay, let's try like this. I still cannot see it. Why can't I see my... Okay, let's do that. Let's do bigger. Okay, and let's go white again. Alright, let's say we have one object like this, right? And let's say we have another one like this. So center of mass creates a constraint here, and then basically this is your rotation area. However, when you go surface points, it creates more on the surfaces. So if you have, where did my Krita go? Here. So you can have a rotation axis that is right at this edge. So then this guy will rotate from here, and then it will end up it can end up like this, right, from here. So it's kind of like makes things look like they're bending a bit better if there was a gravity applied, in a very short explanation. Of course, the purpose of the tutorial is that to show that there are these options, and it's always good to give it a go, to just, you know, play around, you know, like I'm doing now. I have a little, you know, test section. We're gonna test it out and say, okay, this is working fine, and we'll continue with that. So anyway, so we converted now our constraints to hard, and you can see that information if you plug the output of the constraint geometry. So if the rest lengths, they're length, and then they're hard. Now let's configure our objects, because we are still not packed objects. So that's Rbd configure, and drop it in, so that the constraint is still traveling with us. So here now, this is, I didn't change the settings, but these are the things that you can change and feed into the simulation. Like, what kind of collision group is this? Do you want this object to collide with some other object? Or you want this collision group to ignore some other collision group, so they don't collide with each other? Do you want to put speed limit? Do you want to create deforming objects, so on and so forth? Some mass attributes, and there's some other constraints that you can all assign. Pretty cool stuff. Now what I'm doing next is that I'm going to bring in my animated ground, this guy here. So let's drop in. I don't like too many crisscrossing wires, so in landscape, I want now isolate what's at the edge. Okay, so how we're gonna do that is this, like this. Let's go in here. We brought the landscape in. We still want to be able to see what's connected somewhere if they're selected. So this is under view, show height selected nodes in the dependency links. Okay, so when you select, it says, oh, I'm coming from somewhere, and then you can see where it's coming from. It's very useful. So we have now this edge, not all the edge, so let's but because it's animated, so we need to pull this to the first frame with a time shift, in this case 1000. So let's go to 1000. Okay, so I'm gonna put a wrangle, wrangle. I'm gonna call this f at cliff equals 1. I'm gonna do the opposite on the other end, which are my rocks. It's not a cliff really, but not cliff 0. Make sure this is correct as well. Cliff. Okay. Now let's do a little attribute transfer. There's gonna be from this guy to this guy. It's gonna be just the cliff, and my current value is 75 meters. 75. Okay, so if I visualize this, I should have a cliff value, and some of this should be 1. So now what I'm going to do is that I will create a group called static if the cliff is bigger than 0. So I want to group the static group. Well, they're not really static, they're going to be deforming. Attribute wrangle again. So let's say set edge group, right? Here's a little thing. So it's actually quite surprising that I see that a lot of people don't know that these exist, that they're really handy little snippets, and I use them all the time because I always forget the syntaxes. So you can go to so what one is to create point group based on a threshold of an attribute, which in this case is cliff. So we're gonna name this static. Well, it's not static, I think it's deforming, but I named it static, so we'll just leave it as it is. So we don't need this to color it. Then if I have a look here, now I have a static group that is 635 pieces in this group. Now I want to set conditions, default conditions for my objects. So it's an attribute wrangle. We could have done this in the Rbd configure as well. I just kind of did it later. I think that's like I'll show you both, it really doesn't matter. So I said these objects, all of them are not animated and they are all active. Okay, which is now pay attention to the points. There's active and animated, so I can disable that and I can actually say the same thing here. So I don't know why I did that, so let's keep that one. Now I want, actually let me undo that. I want to say, so I have this active, but I want to say if they are static though, in the static group, then I want them to be animated and not active. Okay, so if I do a blast to show you which objects are going to get affected, if I go static, reverse, so, and if I visualize the edge, so now all of these will not fall, everything in the center will fall, and if I want that to be a bigger or smaller area, this is all I have to do. Okay, so now our edges are even nicer than what they were before, so it's a bit more natural way of destroying things. Let's put a 60, 65. Okay, you don't need this at the moment. Now what I need is that they are going to be doing their motion. So how am I doing that? Is I can actually, why, I don't know, let's use the proxy. That should be a faster way to do it. Instead of using high res, let's see if it's going to change the look. I think it's better to use the proxy. Let me do the blast just to check if there's a big difference. Just little optimizations along the way as we recreate the scene. Blast as opposed to the other guy. Okay, interesting. Is it because this has more points on the edge, or maybe because this is not detailed enough? No, it's all right actually. Let me quickly debug this. It bothered me. So let's go here. Okay, and time shift, good. Attribute set here as well. So blast doesn't blast anything. Is it because the distance is not much? Okay, the distance is too much. Okay, so let's go 30 then, or 25. So again, like we had to adapt. I think that's because this has more tetrahedrals right near the surface, so it's picking up more objects easily, much easier. All right, anyway, that's cool. So now let's do a section that we want to animate. So we want to create a little point deform. Of these edges. So let's do point deform. Okay, so at this moment these guys are not affected, so let's plug this guy into the left. Okay, we need a time shift, which is this one, and then it's like this. So but this shouldn't work out of the box, but let's give it a try. Oh, it's working fine. Okay, so it's working fine, but I think we just want this to work on the static nodes. All right, so now our edge is following our landscape as well. So then we just need these pieces to follow these edges using the glue and the dynamics, and then start breaking apart in the center, obviously. All right, cool. This seems to be working. So this is now null. Let's put a null and call it out simulation pieces. Now let's get our constraints. So what I do with the constraints is that I put a little delete swap. Actually, let's do something like this. This is a bit nicer way to work. So this is our simulation pieces, right? Cool. We don't need this guy. Let's move this guy here. Actually, I'm gonna do something like this. Let's move this further down to the left. Let's now extract our constraints let's name them out constraints. Out constraints. Okay. What I do with these constraints is there's a little cheating I do. I put a delete, and sometimes I delete random pieces. Let's say in this scenario, like if things don't break faster, if things don't break as fast as you like them to, so you can just remove some of the constraints, and this is what I do. So in this case, I'm removing a lot of stuff, but we can play with these numbers. So let's bring this guy next to here. So this is the constraints. Okay, and we have the proxy landscape, which is going to be our collision geo. So we can do another null, call it out collision. Excuse me. Collision, and this one goes to the landscape. All right, now we're actually ready to pipe this in to our solver, but in case we end up doing some additional work, what I usually do is actually let's color these properly as well. So this is the Rbd prep. So the buildings are a lot more complicated than these ones, and so can be these landscapes, but I spend the additional time on creating the constraint network for the buildings, which is something like this. Let me bring it in the other scene. So this whole section here for buildings is this entire section. So obviously it's a lot more sophisticated, but in principle it's same. It's just because they're different types of geometry. Let me check the recording time before moving forward. Okay, we can still continue more. All right. Where are we? Yes, so this is now the, let's name this section the edge drivers. Okay, now let's put an object merge, and let's say in sim pieces then duplicate in constraints, in collision. Like imagine if you want to add some stuff later on for collision, so on and so forth, it's like it gives you a little room for organizing your scene. In collision. All right, so this one goes here, this one goes here, this one goes here. Okay, now we are going to drop in because these are in and out connected. What I want to do is maybe give them a similar color so we can follow up. It says in and out, you know, they're connected. Let's name these. No, let's not do like that. Let's delete this one. Let's call this simulation dop inputs dop dependencies, and these are dop sources. Okay, now let's drop in an Rbd bullet solver and hook up our connections. So the first one is obviously the required geometry. So I'll go to the first frame here. If I turn this on, and this will just probably fall down now. It's just the scale is so big that it's falling down really slow, but it is. Okay. Because this is, if you remember, this is like 200 meters in x-axis. So from here to here is like 2 football fields. Okay. Next thing is there's one thing I skipped. Sorry, let's do that. Here under, just before the constraints, what I did is then I put a primitive warp, because I'm overriding the strength of the glue, so I'm making it weaker at the center, so it kind of cracks open at the very center first, because we don't have like a real world structure here, so we kind of need to cheat it. So how do I do it? It's based on the x-axis. So let's drop in a relative bounding box, and I connect position to position, okay? And now I'm interested in x-axis, right? So I put a vector to float. So what does relative to bounding box do? If I do a C, if I do the CD here, and if I visualize this, it gives me these world position for colors, right? But if I extract the x-axis, and then it's gonna give me an x-axis fall off from 0 to 1. Now all I need to do is to remap this by using a ramp attribute. Ramp parameter, plug this in, and now I output this attribute so I can use this inside my simulation, which is going to be G mult, glue multiplier, as I named it. So we don't need the color. Well, actually we need the color so we can visualize it. And then if I go to primitives, I'm going to see an attribute called G mult. G mult here. Well, okay, it's not supposed to be a vector. There you go. All right, it's a float. All right, cool. Now the next thing is it's outputting as a vector, because actually I want this spline, so then we don't have to worry about it. It's going to be correct. And let's plug this guy in here so you can see what it is doing. Right now it's 0, because when you go spline, it's a flat. So in my test, it's kind of something like this. So it's on here, also on here. However, another one here, another one here. It's kind of dark in the center. Okay, so now this, obviously this glue will easily break from here, and the things will start hanging, bending. It's a bit easier. Okay, and I am also kind of animated these over time. These guys go left and they'll go right, so I'm going to copy that now so you can do the same thing, which is the exact same thing. It's just that it's animated over time. Is it moving? Yes. So if I plug into the color, it is plugged into the color, but it's not visible that much. Oh yeah, it is, because it's really high. But this is what it's doing. It's the same thing, except though it's if I actually move this down, you'll see that it's doing that. Yeah. So to make sure that it's things are falling over time, it's a bit easier, because things were not falling. All right. Back to our .NET. We need to plug in now the glue network. Constraints go here. Collisions go, if you do a mouse over, collision goes here. Okay. So there's other ways to do this. Like, we didn't have to do this point deform, but then why did we do it? Because we can. You could also use the guided geometry input, guide sim, to guide the edges, but we're gonna use. I will show how to do that as well in the building simulation. But this is like a very similar thing. That's one of the good things about Houdini, right? You can do many things in many ways, and if you don't know how, they make the tool for you, like this guide sim, and then you can dive in. It's a more sophisticated way of doing guided. And then if you do Control F and guide, it's gonna be a guide capture. And then if you can follow your way back up, you can see, I think, how they are doing it. Guide here, dive inside. So there's a lot of stuff happening. They're a bit better. There's more options, but this is, this works. For this purpose, for the building, we use the guided, which is nicer. Anyway, so let's go to now solver settings. And let's go to collisions, and then we're gonna change the collisions to create deforming static object, because our side walls are actually deforming objects. Let's go to constraints, and then breaking thresholds. So for soft and hard these are the numbers I ended up with that worked for this current value and current screen size. You are free to experiment. Force threshold is 10 million, I think. Yes. And there's a little variation, and it's scaled by an attribute called gmult. And then also things will break if things are hit by other things. That creates 200,000 excess force. Update from input. So update from input means that because it's animated here, so it's going to inherit that. Okay, let's press play and see what it does. But before we do that, let's save. Okay, so now what we expect to see is that it's going to start breaking here, it's going to start hanging, and it's going to break, but we are still using the glue that I wasn't using, but it's worth a shot. So let's press play and see what it does. Okay, so let me pause this, then I'll make a flip book and we'll come back. Okay, so the flip book is finished, and I was doing a test with the surface points too, but honestly I think with these settings it's not really worth the extra effort because it's usually a bit slower. So let's stick to the glue from the center. It may look like it's breaking a bit too easy because it is. So you may want to make them a bit last longer. Maybe it's again, this is like a creative feedback. It's up to you, up to your taste, what you're designing. But in this scenario, because my camera is kind of like following the destruction, so I wanted to be able to see some chunks that are still together for a brief moment. So it kind of here is still have, and then it kind of breaks away, and then just falls down. So so in this scenario it works fine. So let me stop because I was cooking something on the back. So then I disabled our test blast, loaded everything for one section, and then the rest will be simulating. Let me reset this. There's another thing that I didn't do, but I would like to show how to. So I'm just gonna put that back on because this is kind of soil, and it does kind of make sense for this to work. Why is it not working? Cooking was, yes it was, I interrupted it myself. Okay, this on off. It's just a better, it's not supposed to be there, I guess. Let's go here maybe. Let it cook. No, do I need to save and open? Come on, this is stupid now. And it's not gonna cook it until it is proper cooking. Yes, it was interrupted. Okay, let me save and reopen Houdini. Okay, so where are we now? This is working. I want to test this area again, so let's keep doing that because I didn't do it for my promotion video, but I actually want to implement this. I think it's a pretty cool feature. So just let it bake its things. It's actually taken a while to do the embedded TED-Geo. Well, since we are, well, we don't need this here for buildings. We're gonna need it. Okay, let me press play again until they kind of come apart. And then we're gonna look at these deformed pieces because it's kind of like a soft area. Let's say it's land, so it kind of like would, I guess, do a little stretching before it breaks apart. So let me see if I freeze on this frame and then bring it in Rbd deform pieces, hook this up, let's use constraints, maybe name. Do we not have name? This should work. No, it's not working. Attribute name does not exist on the input geometry. It's awkward. It does here. No, it does here too. What do you want from me? Maybe it's looking for this one. Yes, also proxy geo. Oh, we didn't connect the proxy geo. Oh, we should do that. It's for speed reasons actually. Let me remedy that. This is also very important, proxy geo. So let's go in constraints here. Let's say proxy geo in proxy geo. Why not use it when we can? Let's move this a little to the left. I mean, our geometry is not heavy, but if we did the internal detail for these pieces, it may end up becoming a problem. So if I go null and output this, it's gonna be kind of like the same thing, because our proxy geo is not. We don't have a proxy geo. We didn't brought it in here when we did the material fracture. But if we did, all we do here should have gone from here. So it kind of like deforms the proxy geo. This is the proxy geo, okay? And our hero piece will be here. So this will go null here. So there will be alt hero. So if you like, if you have interior detail, right? So in here, this goes in here. So it comes in here then. And all the attributes that drives the simulation should go from proxy. And if I put this in here, now I should have a proxy output, which is exactly the same as hero output, because our meshes are same. And if I press play, exact same thing should happen, because proxy will drive the hero now. So let it cook a little bit. Okay, so that's coming apart. So there is actually a neat tool called .io. No, sorry, Rbd IO. And Rbd IO actually saves a static frame of your hero and then saves the moving objects as a point. And it's like much faster to it, and actually transforms the cached single frame high-res geo with the rest. But this is not how am I doing this here. And I'll show you why, because I kind of, it still doesn't have the like it caches a few things inside and it doesn't have one input point. So I kind of think it was easier to do it manually. That works with the tops. So that's why we're going to do our manual way. But if you're doing testing on your own, you cache this guy out with the rbd.io. So let's try this guy again. You go here, you go here, you go here. Alright, so now it's working. I don't have to do anything. So what it does, and if I put a normal sub here, I need to fix those edges, but so the edges will start snapping away from each other, but there has to be a better fix for this. I think there was a edge fix in Rbd. I don't remember though. Convert constraints, bullet cluster, configure. No, I don't remember. So, but let me simulate a bit more. So what happens is, let the pieces come a bit apart more. So if there's pieces that are angled in a, next to each other with a low angle and close proximity, it kind of keeps the edge faces next to each other. So it kind of feels like it's going, it kind of feels like it's stretching just before it breaks, right? So there's a radius here. Let's go maybe 2. Let's go like this. Okay, it started coming apart. Oh, maybe we need to do the constraints. Okay, I think this is gonna work like this. So we increase the radius then. I think so, like this. Let's scroll back a little bit. Okay, I am not sure why this time it's not working. It was supposed to be closing based on the constraints, but it doesn't seem to be doing it. Maybe it needs to be more. Yeah, maybe it works better in smaller scale. So let's ditch that for now. And if I come up with a solution, I'll make an extra lesson about it, free of charge. Okay, so we're gonna cache out now, but we're not gonna cache out the geo. We're not gonna cache out the proxy geo. Also, we're gonna cache out instead the simulation points. So that's gonna take a lot less space, obviously. And we have everything else in our scene to be able to transform our pieces. So how does that work? First of all, we have to set that up. So these are inside simulation, right? So let's go here. Let's leave this guy here. So we're going to cache this out. Let's call this out sim PTC, out sim PTC, and then we're going to go geo object merge. Sorry, object merge. We're going to bring in our hero pieces, which is this guy here, in hero pieces. Then we're going to put transform pieces. So what happens is, first input is the required geo, then we put a time shift, which is the rest frame, which is our start frame, to be not $f, but to be our rest frame that goes into rest points, and then the simulation itself comes into required points. And if you do transform pieces will still move. However, it's going to be so much faster because we're only loading this geometry once, and then we're just loading the points, which is so much faster. Here we have some unnecessary attributes. I think no, these are all necessary except maybe the instance. So let's leave it like this. So now we need to cache this guy out. Cache out when it's wedging without this disabled, of course. So how do we do that? Let's start setting our wedge system. So we go outside. So this is our terrain, obviously. These are our assets. So let's put this bar that's soon to be populated. Assets creation. Next thing we're gonna have under this is that let's do that as well. Oops. And then we can, let's structure it now, then we can fill that up later. Then we're gonna have environment layout. Let's just call it layout. Then we're gonna have ground simulations, which probably that could have been here, but ground simulations. Then we're gonna have primary RBD simulations. Then we're gonna have secondary simulations. Like volumes and particles. And I will continue from there. And then let's put one more down. Let's give them a color as well. Let's go like this. We'll change that after ground simulation. Earth color. RBD secondaries. We'll have pyro. So like this. This is primary. This is also earth. And then let's go yellowish. Let's go orange. For the red for the secondaries. Let's put now one more. Top networks. So let's drop in a tops. And let's call it simulations. Okay, let's dive inside. So now let's find our ground simulation. So what I'm doing is first I am baking the height field. So let's structure that a little bit as well. Let me check the time of the recording. Okay, we are close to an hour, I think, or past already. So I need to probably split the video, but let me do the simulation first so we can do the RBD. Where is the ground simulation? On mine terrain VDB. This is the ground simulation. Okay, let's drop in a ROP geometry output. Okay, and then we're gonna put a wedge node. And we're gonna call this change cracks, change land RBD. Yes, and so we had 5 primitives, as you guys remember. I'm gonna pin this. I'm gonna go there. So let's run this first. So it's empty, right? So it's gonna give me as now 0, 1, 2, 3, 4. So let's pick one. Now let's go back inside the terrain. Let's press this plus button on the wedge attributes. So what we want to wedge here is the target parameter, enable. We probably don't, you don't need to do that actually, but you can push like this. So where is our wedge? Change wedge here. So let's bring that one here. Parameters, pin. Okay, so I want this guy dragging and dropping it here, absolute, and then it's going to be like this. And I want to name this wedge cluster ID. I'm just copy pasting it. That's the name of my wedge, and it's an integer, and it is wedge count minus 1. Because these are actually the value that is going to be driving this. So it's going to do 1, 2, 3, 4, right? Okay. So it's going, every time I click on, let's put the visibility here. Okay. And then let's put the landscape like this. I'm going to pin this viewport. I'm going to go back into tops. Now if I press a different button, it didn't work because I didn't set this yet. Sorry. You need to now get the attribute name and tell it what is going, where it's supposed to be affecting. In this case, it's @ the attribute. Okay. So now it should say it's 0. It should be 1. It didn't change. Why it didn't change? Let's check. It's supposed to change. It's giving me an error. Local variable, which cluster ID not found. because I changed the name and I didn't run it, I guess. Let me try again. Okay, it's working. If you change some stuff, you need to run it again. So then you can click on these buttons and it's going to switch areas, right? So we all have to tell Houdini now is to simulate for each one of these to an X amount of frame. So that's easy. We will name this now Rbd land sim. Rbd. These namings are now important. And sim, it's gonna keep. So like if anything else you cache, you name them all Rbd, whatever, or just, you know, maybe one is too much. Now, what do we want to cache is going to come to swap path. So we want to use the points, the outputs points coming in here. You need to tell the frame range, which is 1000 to 1500. And our path is going to be something like this. I'm copying it from the other side. So we don't need the dollar project because we are going under dollar hip, unless you're going under somewhere else. So I'm going to remove this here. Again, these parts are up to you guys. So now it's going to be like dollar hip is my Apocalypse Inferno, and it's going to be like Geo Rbd land wedge 1. So version 1, wedge 0. So when it switches to another one, that value is going to change now to wedge 2. And what I do is that then I have my, so basically I have my version, wedge number, and then I have my frame number. All I need now is to do to tell Houdini what to cache. So let's go back to terrain, and this is what we want to cache. Drag and drop this guy here, and it will start spinning out files. Then we can load them in here to visualize. Then we're going to change this, of course, with a file merge because we want to be merging everything. And then hero pieces will be all of this. Where is all of that? It should be pointing to everything. Or we can do a loop as well. Not really. That matters as much. I believe it comes from the hero pieces. I'm checking my other scene. Yeah, it can probably come before the sim group. So this could be it because the same name. This could be that. Okay. Anyway, we'll get there once we cross that bridge. I'm thinking now. Okay. So the last thing for this video that we need to consider is what we can simulate with what we have. How fast can we do things? So nowadays, a lot of people has a lot of cores. This is an older CPU now. It used to be top of the line. This is a Threadripper 1950, so it's the first gen, 16 cores, 32 threads. So I have a fair amount of memory, but when I started it was 64 gig. So what you can do is that we try to saturate our cores as much as possible without filling up our memory. So we need to say, okay, one of these costs me, I don't know, 20 gig, and I have 64, so I can run 3 at a time. In that case, we're gonna say something like this: local scheduler. We're gonna go to job parameters. We're gonna say, I think it was, let me check on my other scene too. You can actually overwrite locally here. So you can do something like this. You can go to schedulers, add job params local, if this is a local one. Then it's going to automatically select which ones you want. And then you click on this right arrow, it goes there, apply, accept, and then you'll have the options in here. So now what I did in my this version change. Oh, actually, look, this is pretty cool. You can actually limit now by memory as well. So I need to now adapt to that. So you can limit the max thread. So for example, I have 32, so I usually set 30 or 31, at least one core to leave it for my system, right? And then you can say, so if I say use 30 and slots per work item, if I say 5, it's gonna launch 6 jobs at a time. Okay, I don't even have that many wedges, so I'm going to say 10. So it's gonna run 3 simulations at a time. I have never used the minimum available memory. I guess if it's certain less amount is available, it's not going to launch a new job, which is probably a good, like a limiter. Then the next thing you need to do is this. You just right click, let's save, obviously, in case it crashes. Right click and cook selected, and it will start running, and hopefully it will start increasing more. It should pick up more. It didn't. Oh, we needed to do something. Sorry, we made a mistake. Kill. It's a simulation, so all frames needs to go in one batch. Okay. And I don't think that's necessary, but I do it. I think this is a. I don't care. I don't think it really is necessary, to be fair, because we are saying all in one go. So let's do it again. Slot setting, slot count to maximum value. Not enough tasks to run. Okay, so it's kind of like smart now. It's because there's 4 jobs instead to 4 of them, but it should have launched more than one, which it didn't. Okay, let's check the folder, because it should be creating additional folders in that case at the same time. It's supposed to launch simultaneous simulations. So right now there's only weight 0. Okay, let me double check this. This doesn't feel right. Local single slots per work. Okay. Rule. This is fine. Service. Schedulers. Oh, is it doing it maybe? It starts simulating. No, it's supposed to be like 1 and 2 at the same time. Open here. It's only doing 1 sim at a time at the moment. Let's kill it. Kill. Okay, let's try instead. We did this already. Let's try drag and drop the schedule. And let's try to use this scheduler. So slots 10. Then let's do 8, right? We're saying 8. This should still work. Let's try again. And I was saying 8. Let's put 8 here too, in case. Okay. This is a new feature. That's pretty cool. You couldn't see that before. Alright, I need to investigate why it's not picking up more. No minimum. Yeah, we don't have minimum, so it needs to pick more jobs. Let's kill it again. Let's drop it to, I don't know, 3 to see if it's going to pick up more. 3. Let's hit cook selected. Okay, now it's picking 2. The numbers don't make much sense, but we'll have to investigate this. But basically, the rule is I have 5 wedges. 0, 1, 2, 3, 4. Well, 5 wedges, yes. So I have 32 cores. So I should be able to distribute my cores against the tasks. So if I do 6, it should do 5, because 6 times 5 is 30. So it should actually launch all at the same time, but at the moment it's not doing. And so I'm thinking something has changed between the version I was working as opposed to the current version. now it's maybe picking up more, and maybe it's okay. So it has two of them running at the same time. Maybe it's gonna add up more. Maybe now it kind of learns over time. I'm not sure. All right, so just let that cook, and we'll continue from the next video. And I'll stop this chapter now.